CNT125. We're working on Chapter 12. I'm backing up just a slide here. The end of the last podcast ran short, so I want to make sure I hit both of these concepts again real quick with you. Quality of service. Quality of service. Two different ways you can do quality of service: diff serve field and class of service. So let's take a look at diff serve field real quickly again. This is looking at quality of service at layer 3, prioritizing traffic at layer 3. So it's going to take into account all types of network traffic, but can assign things like voice streams a higher priority as opposed to regular web surfing data, if you will. It does this by looking at the diff serve field in your IP4 packet. If you look at your IP4 header, there is a diff serve field here. That's one of those fields that you mentioned back in 120, but kind of moved right beyond. Here, as we look at quality of service, this field can get triggered or tagged, and we can reference that, or devices can reference that to know how to handle this, whether it gets priority or not. So diffserv places into the diffserv field of an IP4 packet a 6-bit. First 6 bits of this 8-bit field are called the differentiated services code point. That can be triggered to let you know that this particular packet has priority over just web data. This voice packet, this IP voice packet, has priority over the data, this regular web data, if you will. In IP version 6 packets, the diffserv uses a similar field known as the traffic class field. Hopefully you remember seeing that in your IP6 headers. And it indicates the network routers how the data stream should be forwarded, whether it takes priority over something else. And that can get done through an access list. You can permit a particular type of IP traffic by matching the packets to a given DSCP. Two types of forwarding: expedient forwarding or assured forwarding. Here, if I look at the DSCP value, here we go. If I set it to this for phone, I'm going to do expedient forwarding. If I set it to this for conference, assured forwarding. If I lose a frame or two, okay. But the IP phone, I got to make sure I get it through so it can be heard. And that can be done here when I do this access list line here. DSCP expedited forwarding. I can assign it there. The other technique is a class of service. Quality of service refers to a technique that are performed at various OSI layers via several protocols. The class of service refers only to techniques performed at layer 2 on Ethernet frames. Class of service most often used to efficiently route Ethernet traffic between VLANs. So if I take a look at your tagged frames, here's your tagged frame here. Contains a 3-bit field and a frame header called the priority code point. Set these bits to one of 8 levels from 0 to 7. Indicates how the switch prioritizes these messages, if it needs to give priority versus something else that it's handling. And here can be a class of service. Here, if I have these particular DSCP values, I can set a class of service value like so. And I can have this be basically more important than this. And this is handled at layer 2 now. Here is some class of service configuration that can be done. In a particular VLAN having priority. Maybe a voice VLAN having priority over your data VLAN, if you will. And that can get handled at layer 2 versus the quality of service diffserv field getting handled at layer 3. So these are some different ways you can do some quality of service. Moving to the next section of the chapter, they talk about response and recovery. Despite any precautions you do, you're still going to have things that are fail, or it's things that are like security breaches that are going to happen. So training and preparation can make a difference on how do you respond to, how quickly do you respond, and how quickly do you adapt to a situation. In most companies, they're going to have usually planned days that you do response or recovery drills, whether you have a power outage or what. And they literally do plan for these and try and see how people respond to. Sometimes in a school it's done over the summer, so it doesn't affect student environment, but in a business or someplace that runs 365, these have to be done while things are going on. And how do you respond to them? So an incident is an event, large or small, has adverse effects on a network's ability or resources. Could be a security breach, could be an infection, could be an environmental issue like a fire or flood. A disaster is a pretty extreme incident, network outage that affects more than a single system, or maybe in a prolonged time, if you will. So, incident response plan. Define the characteristics of the event that qualifies as a formal incident and steps to be followed as a result. And you might delineate certain things. How do we handle break-in? How do we handle fire? Weather-related emergency? How do we handle hacking? Etc. etc. And the plan or the intent of this policy is to keep people safe, protecting the data, whether it be customer data or health records, that sort of thing. Ensuring the network's available, collecting data, what went wrong, who's responsible, what action should be taken in the future for prevention. That's all part of your incident response plan. An incident response is usually a 6-stage process with these steps here, and we'll break them out here. Preparation. You need to do some preparation ahead of time. Chances are, wherever you work, there's already something in place. There's already some kind of response plan in place. But being the new guy, you'll probably be brought up to speed on what that is and what your role is in particular incidences. But preparation is going to be some brainstorming of possible incidents and how to handle them. And maybe installing backup systems and other things ahead of time that you can use to recover from the incident, and have things in place that allows me to recover from an incident. Step 2 is detection and identification. How am I going to detect and identify what the problem is? Now you go back to your monitoring software. Now you go back to your management and a simple network management protocol, management stations, those sorts of things to know how to know when there is a problem. And these alerts get raised and shared, and who do they get shared with? That the right people are aware that there's an incident. And then when there is an incident, do I need to escalate this to include more people, or is it something I can take care of on my own? Okay, so that needs to be part of a plan too. Containment. If it's something that needs to be contained, maybe like a data breach, how are we going to do that? What's getting affected, and how are we going to isolate this? Remediation. A person or a team needs to find out what caused the problem and begin to resolve that. Whether it be a data breach or a failed drive or a failed router or a failed switch, how are we going to remediate this? Step 5 is how do we recover? Do we need to recover any data? Do we need to recover any information or whatever? How do we recover from this fault? And then 6 is going to be a review. We need to review what happened, learn from it, make adjustments, and maybe change your plan to how we respond to that particular incident. Maybe our response was good, we document what we did, maybe it was not so good, so we need to rethink and adjust our plan on how we're going to respond to similar incident in the future. Response plan should have a number of members on the response team. And they kind of define these roles here. Dispatcher, the person on call who first notices and alerts the problem and basically alerts the correct people. The technical support specialist, this is the one that's trained in that particular area. Maybe it is a router failure. So who's your main router person or your firewall failure? Maybe it's, your firewall person. Who's the right person to respond to this, or team of people to respond to this particular incident? Manager, the manager is going to coordinate the resources, whether it be the people or in-house or vendors. They're going to coordinate the efforts to respond to this incident. And they might just be kind of like the director, the director of communicating between these people and organizing these people. And in some cases, you might need a public relations specialist if necessary, whether it be a company or something that you need to communicate to the public what occurred. We did have a data breach. All records are identified as, nothing, Visa card or health information or social security numbers. Those were protected. None of that was leaked, but this was leaked. So communicate to the public what has occurred. This brings us to data preservation. During some incidents, data will need to be collected in such a way that it can be presented in a court of law for the purpose of prosecuting an investigator of illegal activity. Some of the forensic data available for analysis can be damaged or destroyed if improperly handled. So how do we do that? So IT technician needs to know how to safeguard that information, log the data, other legal evidence for first responders. So with data preservation, we have these steps we need to do. Let's take a look at these real quick. Secure the area. Prevent contamination of any evidence. Device involved must be isolated. Could be a laptop, could be a desktop, could be a server. We need to isolate that. Devices disconnected from a network. You might remove the cable, you might remove the Wi-Fi, that sort of thing. So no one else has contact with it until your response team arrives. Ideally, leave the device as is. Don't change anything. Don't change any applications or files or anything. And kind of treat that area as a crime scene. Document the scene. You need to do a documentation of what has gone on, who's been notified, what has been changed, that sort of thing. And document all that so they have that information to refer to. Don't leave the area unattended. That might change what happens. Somebody might actually be able to get in and do something to it or reverse what they did. Monitor the evidence and data collection. Record all the items collected for evidence. Take care to preserve all this in its original state. Don't attempt to access anything. Protect the chain of custody. If you now have data, let's say they do pull out the hard drive for evidence, that needs to be documented as to who handled it and what handled it, kind of who and what handled it, so that you have a chain of like where this thing has been, because if you don't know where it's been, you don't know whether it's been tampered with. So you need to have a chain of custody of what particular thing is maintained by who and how. Monitor transport of the data and equipment. Okay. Again, you need to make sure you're monitoring this so it's not seized or swapped out or anything like that. And then create a report. You need to report anything that occurred, and you need to do it sooner rather than later. It's hard to remember details later, so it needs to be done now when things are relatively fresh in your head. So you have that to refer to, because it might be months until you come back to this particular event. Disaster recovery planning. Disaster recovery process for restoring your critical functionality and data after an outage. These account for kind of the worst case scenarios. So you should provide contingency planning for restoring or replacing computer systems, power, phone, files, etc. The goal of this is to ensure business continuity. Can the business keep functioning when we have this particular event? A disaster recovery plan should include the following: names and phone numbers for emergency coordinators, and this needs to be updated. Think about if you've changed your phone number, or email, that sort of thing, or your job role changed and somebody else got hired to take your place. All that information needs to be updated. It needs to be checked frequently and tested, if you will. How are things being backed up? Where are they kept? How often are they kept? Details of your existing topology, redundancy, agreements with carriers, that sort of thing. Status strategies for testing your plan, and a plan for managing any crisis that occurs. Organization can choose from several options for recovering from a disaster, but they are going to cost different amounts of money. Hot site will be the most available or useful, but it's going to cost the most. Cold site is going to be cost the least, but it's going to take longer to get up and running. So as I look at these, cold site, the components necessary to rebuild are there, but they're really not configured or connected. They're just maybe sitting on a shelf, if you will. But I got to get them out, power them up, connect them up. I might even need to install things on them. Warm site is the components necessary to rebuild exist, and some are already maybe in place and running and configured. Hot site is literally like a duplicate set of equipment. It's ready to rock and roll. I can literally just plug into it and I'm ready to go. Some places do that. They'll actually build a second rack of equipment to test network changes and then move it to the live one and keep that as a backup. Some places do that, but that's very costly. That is very costly to do. But that's all part of disaster recovery planning. We'll come back in the next one and start talking power.